Welcome to our second module entitled Graphing Polynomial Functions. So our lesson 1 is the leading coefficient test. So the activity in your module, the what's new. So the activity you have just answered will lead you to the new topic, which is the leading coefficient test. So this test can help you determine the end behavior of the graph of a polynomial functions by looking at the degree in the leading coefficient so that it will give you a rough sketch of the graph. So let's start by reviewing the definition of a polynomial function that you have learned in the previous topic. So a polynomial function is a function of the form, okay? So where a sub n are real numbers called coefficients, and n is a positive integer, and a sub n x to the power of n is the leading term. And a sub n is the leading coefficient, and a sub 0 is the constant term, and a sub n is not equal to 0. So end behavior is a description of the values of the function as x approaches to positive infinity or negative infinity. The leading coefficient and the degree of a polynomial function determine its end behavior, and it's very helpful in graphing polynomial function. So this is our have to memorize or have to take note of the polynomial end behavior. Okay, so we already know how to determine the leading coefficient and also the degree. So if the leading coefficient is positive, meaning positive ang leading coefficient, and if it is even, the graph is right? This is the behavior of our graph. The graph rises to the right and rises to the left. Okay? So meaning, if our leading coefficient is positive and it is even, the degree is even, the behavior of the graph is rises both, no? Left and right. If the leading coefficient is negative, and if it is even, the graph falls to the right and to the left, no? Okay, that is negative even. If positive odd, meaning add the degree na odd in positive leading coefficient, the graph rises to the right and falls to the left, no? Rises to the right and falls to the left. Then we have negative. Okay, the negative in odd negative leading coefficient and odd the degree is odd, the graph rises to the left and it falls to the right. Okay, so have to take note, no? Okay, let's uh, determine the behavior of our polynomial functions. Okay, for number 1, we have f of x equals 2x to the power of 4 minus 3x cubed plus x minus 1. Okay, our leading coefficient is what? Our leading coefficient is 2, right? Our degree, what is our degree? Our degree is 4. So, by our definition of end behavior, no, our behavior, if the leading coefficient is positive, this is positive, right? Diba ang leading coefficient is only positive and negative? The degree is odd and even. So, this is positive, even. Okay, degree is 4, 4 is even. So, what is the possible graph of, or the end behavior of this function? Okay, meaning the leading coefficient. So therefore, the graph, okay, the graph, say behavior, the graph rises to the right and left. Okay, why? Because the leading coefficient is positive. This is positive, no? And it is even. No? You have to check sa inyong table, no? On page 3, if positive even, the graph rises to the right and left. So, possible the graph looks like this, no? Ana. Okay? Wata kabalo siyang mga turning points, no? Inanha iyahang graph. Okay? Paibabaw ang both ends. Then this one, we have negative 3x squared minus 6x plus 4. Our leading coefficient is negative 3. Our degree is what? Okay, 2. So this is negative even. So what is negative even? So negative even is the graph. Okay, very good. No, the graph falls to the right and to the left. To the left, to the left. Okay, so meaning negative even man. So our graph looks like this. No, possible in an iyang graph. No, it's not the actual graph, but you have the rough sketch of our graph. So going downwards. No, since it's negative even. For number and for next function, we have f of x equals x cubed plus 5. Our leading coefficient is 1. No, you can wala kayo makita or we cannot see any number here. So that is automatic 1. And our degree is our degree is, what is our degree? It is 3 and it is odd. No, this is even and this is also even. Okay, so this is odd, so therefore this is positive odd. So it's positive odd. It should be the graph. Okay, the graph rises to the right. To the right and falls to the left. Okay, this is positive odd. Okay, how about this one? So therefore, if we're going to sketch the graph, meaning the graph rises to the right, meaning right siya, then it falls to the left, no? So that is the graph, no? Fall siya sa left, saka siya sa right. Okay, then for number 4, we have our leading coefficient is negative 1, right? So negative 1. Then our degree is 5. Okay, so this is negative odd. So if it's negative odd, that is the graph. The graph rises to the left. Sorry for my handwriting. And falls to rises to the left and falls to the right. Okay, so the graph looks like this, no? Rises to the right. Okay, rises to the right and falls to the left. Okay, so take note, no? Again, if it's positive odd, positive even, upward, meaning upward. Then if it's negative even, meaning it's downward. Then if it's positive odd, okay, this one meaning opposite yung kano. Then positive odd meaning rises to the right and it falls to the left. Then if it is negative odd, it rises to the left then falls to the right. Okay, next. Okay, so graphing polynomial functions. So in this lesson, you will be provided with illustrative examples and step-by-step procedure on graphing polynomial functions. So here are some important details that must be kept in mind while graphing polynomial functions. You have to use graphing paper or notebook when plotting. So the graph of a polynomial function is a continuous because every polynomial function with real coefficients has the set of real numbers as its domain. So furthermore, it means that there are no holes or gaps in which you can even draw the graph without lifting your pen. So also the graph of a polynomial function is smooth. It has no sharp corner and turns are rounded. Okay, so again meaning our polynomial function is not like you have to sketch this is the Cartesian plane, you have to, okay, it should be continuous meaning walay putol, meaning ana siya. Okay, meaning smooth ang curve, meaning the turning points are smooth. Okay. So every polynomial function of the nth degree cannot have more than n roots. That is the fundamental theorem of algebra, which means the graph cannot intersect the x-axis more than n times. So a polynomial function of degree n has n minus 1 turning points on its graph, or the number of turning points is always less than n. Then we have the multiplicity of root r is the number of times that x minus r is a factor of f of x when a real root has even multiplicity. So the graph of f of x is tangent to the x-axis. When the real root has odd multiplicity or greater than 1, the graph bends as it crosses the x-axis. Okay, take notes on multiplicity. Okay, so we have to sketch the graph of f of x equals x cubed minus 2x squared minus x plus 2. Okay, so we first find the behavior, the end behavior of our graph. So using the definition of our leading coefficient here is 1. This is our leading term, and our degree here is 3. So therefore, that is positive odd. Okay, so then the behavior is the graph. Okay, the graph rises to the right and falls to the left. Okay, then second is we need to find the intercepts, the x-intercepts and the y-intercept. So in your previous lessons, if you're going to find the x-intercept, y is equal to 0, and y-intercept, x equals 0. So therefore, this is f of x is just equivalent to y, right? No, y equals x cubed minus 2x squared minus x plus 2. So this is 0 equals x cubed minus 2x minus x plus 2. So we have to find the values of our x. So in finding our x-intercepts, we can use the synthetic division. So I will make another video on how to find the x-intercepts. Okay. So by the way, so later I will make another video for the x-intercept. For the meantime, the x-intercepts here are x equals 1 and negative 1. X is 1 and x is 2. Okay, so therefore the graph passes through the point negative 1 0 1 0 and 2 0. Okay, so later I will make another video on how to find the x-intercepts of our function. Then for y-intercept, this is just very simple. Y equals, we will just replace x with 0 since that is the y-intercept. So that from x cubed, that is 0 cubed minus 2 times 0 squared minus 0 plus 2. Of course, these are all 0. So our y-intercept is 2. So therefore, the graph passes through the point 0, 2. Okay. Then for the next is, we need to find our turning points. So to get the turning point, that is just n minus 1. Okay, so n minus 1, that is, n is the degree, so the degree is 3, so 3 minus 1, so the turning point is 2, meaning katu siya mag-curve. Then we have to graph, sorry no, We have this is our y and this is our x. Okay, so negative, we have to plot this and this one. Then we have negative 1, 0. X is negative 1. So we have negative 1 here, which is negative 1, 0. Then we have 1, 0 and 2, 0. Okay, this is 2. Then our y is 0, 2. So maybe here. Okay, so we will then, these are the points, no? So the graph rises to the right. Okay, so graph rises to the right. So therefore, we will start here. Okay, mag-rise mo siya sa taas mo siya. So mag-rise siya sa right. So sorry. Okay, maagi siya diri. Okay, then. Okay, possible. This is the graph, no? Okay. Okay, so that's the graph, no? We have two turning points. We have 1 and 2. So this is the graph, no? The graph sketch of our graph. Okay, so correct, no? That's for our number 1. Okay, so the turning points of a graph occur when the function is changing values from decreasing to increasing or from increasing to decreasing. A polynomial function of degree n has n minus 1 turning points on its graph, or the number of turning points is always less than the degree n. So the graph a while ago illustrates two turning points since the degree of f of x is 3. No? As you can go back to our um, graph, we have two turning points. The formula is n minus 1, the degree is 3, then minus 1. We have two turning points. That is where no nag-change tong graph have increasing, then you have two turning point. Okay, that is that meaning this is the turning point, then you have the downward. Sometimes a polynomial function has a factor that occurs more than once. This makes a multiple root. So the multiplicity of root r is the number of times that x minus r is a factor of f of x. So when a real root has uh, even multiplicity, the graph of f of x is tangent to the x-axis. When a real root has odd multiplicity greater than 1, the graph bends as it crosses the x-axis. Okay, let's have an example of multiplicity. You have to sketch the graph of y equals the quantity x plus 1 times the quantity x plus 2 squared times the quantity x minus 1 cube. So the first step is you have to the end behavior. So as you can see now, if you're going to multiply everything, our leading coefficient is, of course, that is 1, no? 1, 1, 1 man katanan. Okay, then our the degree. What's the degree, no? We have 1 here, 2 plus 3, that is 6. Okay, so what is our behavior? So the graph that is positive even. Okay, so the graph rises to the right and rises to the left. No, the graph rises to the right and left. Okay, next is we need to find the intercepts. Okay, so this is very simple, no? Kaya it's already in factored form. So to get the x-intercept, this y equals 0. So we'll not use the synthetic division. So 0 equals x plus 1, x plus 2 squared, and then x minus 1 cube. So therefore, we will use the zero property product. Zero product property, we have x plus 1 equals 0, Then we have x plus 2 squared equals 0. And we have x minus 1 cube equals 0. Okay, so we have, so x equals negative 1. And we have, get the square root of both sides. We have x plus 2 equals 0. So we have x equals negative 2. Then we have x minus 1 cube. The same with x plus 2 squared. Get the cube root of both sides to eliminate cube. So we have x minus 1 equals 0. So x equals 1. Okay. So our intercepts are negative 1, 0, negative 2, 0, and 1, 0. Okay. So then the y-intercept, x equals 0. So okay, so y equals, we'll have to replace x with 0. So 0 plus 1, 0 plus 2 squared, and 0 minus 1 cube. Okay, so we have 1, 0 plus 1 is 1, 0 plus 2 is 2, 2 squared is 4, and negative 1, 0 minus 1 is negative 1, cube is negative 1. Then 1 times 4 times negative 1, y equals negative 4. So therefore, the graph passes through 0, negative 4. Okay, then how many turning points that is there are? Okay. Okay, so we will graph na. So we have negative 1 here, 0, then we have negative 2 here, then 1, then negative 4 here. Okay. So again, let's go back no kung if the multiplicity is the multiplicity or the exponent is even, no, it is tangent to the x-axis, no, and then if it is odd, greater than 1, it crosses the x-axis, no. Again, if ang these are multiplicity, no, kani. Okay, we already discussed this, no, in our previous lesson. Okay, if it is even daw, if even, that is tangent. Okay. Okay, if it is even, tangent. If it is odd, that is cross. Okay. So even if it's tangent, it only touches and it bounces back. Okay. Okay, so it rises to the left. So from here. Okay, so this is, oh sorry, this is negative 1. No, this is negative 2. So negative 2 here, it is even. So that is why we have to bounce back. Then we have here negative 1. Okay, laos lang kay this is the negative 1. Wala man siya multiplicity. Then we have to this one and it crosses but mag-curve lang siya gamay, no? Okay, so this is the possible graph. Okay, again, why is it that we have to bounce this? Dili na siya 3 ha. Dira na siya nga 3. Okay, this is negative 2. What is the multiplicity of negative 2? Diba? This is the negative 2. Kani. Okay, I'll change the color. Okay, so this is the multiplicity of negative 2. The multiplicity of 2 is 2. That is even, so that is tangent. Meaning, bounce lang na sa dara. Okay, we have to, anong nilahos man eh? Because that's normal, no? Wala man na siya. Odd man na, no? Crosses lang. Then, we have also here, agi sa diri, then diri. Mag-cross lang siya, but siya mo curve lang gamay. Or mo bounce siya. Mo bounce siya gamay, but mo will continue lang. Okay? This is the positive 1, no? We have this one. You can dire diba kanang part. Then 3 is this odd, so that is it mag-cross lang siya. Pero if multiplicity mo curve lang siya gamay, then it will go through up. Okay? That's for the multiplicity and how to graph functions with multiplicity. Okay, so we have roots. If the root is -2, then multiplicity is even, that is tangent. If the root is -1, then the multiplicity is odd, that crosses, and 1 is odd, that it is also crosses. So for your activity, you have to refer to your to-do list. Okay, so thank you so much. See you next week.